Today's video will have us replace our stock extruder with a dual gear extruder. I show the removal and the installation with two different styles of extruders. As always, I have my preamble about the differences and the general operation of these units. Now there is a lot of information to cover, so on the bottom of the video I added timestamps. So if you want to jump to certain sections or if certain information doesn't apply to what you're looking for, feel free to peruse the time bar below this video and jump to the appropriate section. Now without further ado, here we go. Welcome folks, thanks for tuning in. This video will look at the stock extruder on our Voxelab Aquila. Here I have a stepper motor off a different machine. I have a plastic bracket on the back here that's going to act as the frame in any of our demonstrations. And on top I have our plastic extruder installed. Now our shipped extruder is functional, but it is not long term. There are two pieces that often fail on this extruder. One is here, this tension arm will often crack, or this portion where the filament feeds into the extruder will begin to erode. Now they have added a metal inlet, but I have seen photos of this portion eroded and it was similar to an issue on the Creality Ender 3s. Now with all my Ender 3s, one of the first upgrades I look to perform is to switch to an all metal version. I mention that because with this machine, the Aquila, I was looking to do the same thing. Now I would normally spend around $20 to upgrade to an all metal extruder, and when looking for the Aquila I found that I could upgrade to a dual geared extruder for less than that cost. And not only that, there was a greater variety. I could upgrade to a all-metal dual-geared extruder, as well as an encased plastic dual-gear extruder, known as a BMG Clone or a Bondtech mini-geared clone. Now, could they really be a cheaper option that not only suited my needs, but upgraded the performance of this printer? I wanted to find out, so I bought them both. Now, I only have one Voxelab Aquila, unless Voxelab is feeling so generous as to gift me another one. So I installed one of them on my Voxelab Aquila, and the other was installed on one of my Creality Ender 3s, which for our purposes is the exact same operationally. So what is a dual-geared extruder? To understand that, let's take a look at the stock extruder our machine comes with. This is an extruder stepper motor off of a machine I have that is identical to what is on the machine from the factory, and this bracket here is going to represent our frame. Now what we're looking to replace today is this, the extruder or the cold end. Now that is this entire plastic piece here, as well as these two gears, this gold tooth gear and this smooth gear as well. Now the operation of this is very simple. The main board from our printers calls for X amount of filament to be extruded based on our E-steps. Our stepper motor here will begin to turn and pull forward the filament we have loaded. Now during the operation of printing, retractions will also occur. That is when the printer removes unwanted filament from the hot nozzle so it doesn't ooze out onto your print, causing spiderweb-like artifacts, often called stringing. So the motor will turn in the opposite direction rather and remove filament from the extruder. In our stock setup here, you'll notice the gold-colored gear right here. That is our only tooth gear that digs into the filament and pulls it forward to advance filament and pulls it back during retractions. This gear opposite, where is it, right here, is a passive gear. It has no teeth or grabbing mechanics. It's simply there to apply pressure for the tooth gear and act as a channel for the filament to sit within. Now this setup isn't entirely bad, but it does have some flaws. One major one is slippage. The name speaks for itself, but slippage is when the tooth gear slips or moves without grabbing filament, resulting in the filament not advancing or retracting the amount we want it to. Because this passive gear is smooth and simply a gully for the filament, it doesn't provide any pushing energy. The motion of this filament will be completely controlled by this tooth gear. During long, uninterrupted extrusions or advancements, this really doesn't present a problem, like in the case of us calibrating our E-steps by removing the PTFE tubing and advancing filament. However, in the case of us printing an actual 3D model, this gear is solely responsible for pushing filament out through back pressure, through temperature changes, and more importantly, it's responsible for the retractions, which your prints will have hundreds of. Now, retraction distances are generally small increments. The standard number for our printer with the factory hot end is around 5 to 6 millimeters. However, the speed of the retraction is important as well. Remember, our goal with retraction is to clear the nozzle of unwanted filament, And to do that, the movement is often very fast, say 25 to 50 millimeters per second, which means this toothed gear spins at a high rate, and it alone is responsible for grabbing and pulling that filament backwards away from your nozzle. Now, just as important as retracting that filament is refilling the nozzle and producing the correct amount of filament to then be extruded. Now, this is where our slippage will often occur during these quick retractions and advancements. That's where our toothed gear will spin so quickly that it is unable to properly grab the filament and extrude the amount we need. Now, so what does that mean for our prints? Well, oftentimes small slippages can go completely unnoticed. Over the course of a smaller duration print, 2 to 5 hours, maybe your average benchy, you may not notice any abnormalities at all. It's when we get into more intricate prints with thousands of retractions or longer multi-day prints, 14, 28 hours, which this printer, by the way, is more than capable of handling, that's when we may begin to see the results of slippage. There may be some zits towards the higher levels, or layers rather. You may see some under or over extrusion. It's possible small details will be lost. If you're printing fonts or text as a top layer of your print, it may not be as precise or clear as you need. Now, it's hard to pinpoint because, as is the nature of 3D printing, there are so many factors that affect our printing. So let's try and remove one negative factor by switching from a single-geared extruder to a dual-geared extruder. As the name implies, that this upgraded extruder has 2 gears, which means instead of a toothed gear and a smooth passive gear, this comes equipped with 2 toothed gears. So now instead of the toothed gear pushing against a smooth passive gear, we have 2 gears both grabbing filament and pushing against each other to advance and retract filament. This means more accurate extrusions, more exact retractions, more precise priming of the nozzle after a retraction, and importantly, less slippage. We have 2 styles of dual-geared extruder here. How does one differ from the other? Well, besides one is metal and one is plastic, there are 2 major differences. The first being this all-metal extruder acts just as our stock extruder, except it has 2 gears. Calibrating E-steps will be the same, and so will removing and feeding filament. This encased plastic extruder has its tooth gears driven by a larger gear beneath them. That itself is driven by the stepper motor, which means we now introduce gear ratios because we have several gears working in concert. Sounds confusing. For our purposes, it's not. What it means is that our E-step number is going to be significantly larger than it would be with our stock extruder. Out of the factory, Voxelab Aquila's extruders are calibrated at 93 millimeters per second, whereas this extruder will be closer to 400 millimeters per second. Not a huge deal. Calibration mechanics are all done the same manner. Remove the tube, snip it, measure it, use the formula. Remember that video? However, our stock firmware will not let us increment our E-steps through the LCD screen past, I believe it is 186 millimeters per second. So to do that, we access the printer's terminal and we calibrate it that way. The second difference between these extruders is where we will begin to talk briefly about flexible filaments, TPU in our example. Because TPU can be so elastic, when printing with our stock extruder, during retractions, the filament can wind itself outside the cold end near the gears of the extruder and cause a clog. Now, printers have gotten around this by turning off retraction or printing at extremely slow speeds, but for me, that's really not an optimal fix. Now, in general, dual-geared extruders should be more capable of printing with these flexible filaments than our stock extruder because the additional toothed gear will help hold the flexible, more malleable TPU in place. However, the ability to wind itself out of the cold end still exists, and that's where this dual-geared covered extruder shines. Because this extruder is encased from one side to the other, completely containing the filament path, it will not allow flexible filaments to bend or catch anywhere within this cold end. So we can print at high speeds and with normal retractions. Now, this all-metal one has the tools to print flexible filaments, but will it be able to do so at high speeds? Well, that's something I wanted to find out. I want to take a moment and just clarify, when I talk about the portion of these gears that's grabbing the filament, I am talking about this upper section here, this serrated section. Now, this bottom section here are the bottom teeth that grab the other gear and cause movement, while this upper portion here is what will be contacting and turning our filament. Those are some base differences and benefits to both of these extruders. So now, let's go ahead and get to replacing them. So here is our all-metal dual-gear extruder. This is the link I got it from off of Amazon. As you can tell, it's not even a brand. So let's go through the contents very quickly. All-metal extruder base, the extruder tensioner arm with the gear installed, upgraded yellow spring, 3 screws, 1 flat-headed screw. This will hold down the recessed portion of our extruder base. We have this longer screw that will go through the tension arm. This red sheath that longer screw feeds through. We have a pneumatic coupler. We have a gear that will go on our stepper motor shaft. We have this smaller sheath section. This is what goes into our spring to help tension it. This is the larger screw right here. We'll press against that to add tension to our arm. And then we have a PTFE clip. Now there's not a ton of pre-assembly required here, but we can do a little bit. So we're going to put the pneumatic coupler into the all metal base plate. Next, we're going to take that long screw. We're going to put it through the red sheath. And then that red sheath is going to get placed into the tension arm. And that's really it for pre-assembly. Okay, now we can start with the removal of our old extruder. The first thing we want to do is make sure our extruder cable is removed, as well as power. We want to make sure the power from our printer is completely removed, as we always do. First thing we're going to do is remove this pneumatic coupler. I'm going to use some of the cable ties I have for cable management to get that out of the way and keep it from interacting with us while we're working here. Then there's 3 visual screws that we can all get to right now. We're going to start with this one tensioner arm. And there's 2 other ones that are connecting the stepper motor directly to the base plate, but we're going to start with the one in the tensioner arm. Now, I know this process is super boring, and there's no music, and there's no other thing to interact with right now while I'm doing this, but I know that people who've never done this before find it very helpful just to see the entire process, my pitfalls, how I'm doing everything, just little things that they might have never done before. They can see it all. So that's why I include every part of this during the video. So I apologize if this is boring for you, but I'm just trying to reach that one person out there who's never done this at all and really wants to see what all this might take. So that's the tension arm coming off. And I actually noticed when I took it off, there was no tension screw, which I'm pointing to right here. There was nothing there. So the screw that's supposed to tension my tension arm was doing absolutely nothing. So kind of wild. I also noticed in this next step that my extruder motor itself was extremely loose. Now this printer actually printed extremely well. So it's kind of troubling to find issues like this. So it almost makes you think that maybe occasionally, weekly, 3 weeks, every month, you should go through your printer and just check all the components to make sure everything is as it should be. So finishing removing the rest of these screws. The other 2 are loose, and now I have this one last screw. That's the only one holding the stepper motor in place right now, so I have my hand under it. So once it's done, the stepper motor drops down, and it is out. We'll place that to the side. We're going to remove the old gear off that very momentarily. And now we just take the base plate and we are uninstalled. So here we are taking the old gear off the extruder, leaving the old the extruder motor by itself. And now we're going to insert the new gear. Make sure that grub screw is facing down. So you want the larger teeth to be down. And we're not going to tighten this. We're just going to leave that at the bottom of the stepper for now. So we've pre-installed the pneumatic coupler into the new base plate. So now we're going to place that onto the frame of our printer. Make sure the pneumatic coupler is pointing towards the glass bed. That's what your PTFE tubing is going to sink into. Now we have the flat screw. We're going to place that through the recessed portion of the all metal red base. And then we're going to place that through the frame. And now we're very easily going to slide this stepper motor up. We want to make sure that the plug for the stepper motor is facing away from the glass bed. And then we're going to insert the first screw and tighten it down. So I like to do it this way just because it makes putting the other screws in very easily. Once we have one in, as you can see, the stepper motor is now held up by that screw, so the rest of this process should be fairly simple. We go around and we do the 2 other screws that can be seen. We'll do the tensioner arm one last. You'll see why. It's always a good idea, because we have a glass bed, to maybe put a microfiber cloth or something over that glass bed in case something falls or you accidentally scratch it. You don't want to ding it up too much. I didn't do it in this case, but it's something I normally do, and I recommend for the future. So once we have all 3 of those screws in there, we can tighten them up. And then we're going to introduce this tensioner arm here, and we're going to adjust our screw that's on the stepper motor that we put in the previous step. We're going to adjust that now. So we've lined up the tensioner arm. That's where it's going to sit on the motor. So now we get to bring up the gear that was on the stepper motor and line it up properly. So it's not the bottom teeth, which are the larger teeth. It's not those necessarily that we want to make sure are together. We want to make sure the upper portion, the more serrated teeth, are connected, because that's the portion that our filament is going to feed through. So those need to be lined up perfectly. So that's what we do here in this step. And then after we have the upper serrated teeth lined up perfectly, we go ahead and we tighten down that grub screw. Now, another thing I should mention, when I open this, the grub screw is actually out of the gear, and if that thing goes, much like your hairline, once you lose it, it's gone. So when you're opening up the contents of this extruder, make sure that if the grub screw is out, that you don't just dump it on the table, because if it's gone, see you later. So we tighten down the grub screw, make sure the gear on the stepper motor is nice and tight. And now we can put in this tensioner. Now you also notice I put this screw in right here. I'm not sure if I preloaded that earlier, but that screw is what's going to hold or help hold this spring in place. So after we have the spring on there, we're going to load up the sheath that the larger screw is going to help tension that spring down with. We put that all in place. We make sure that larger screw is going through the frame hole. And then what we're going to need to do is apply a little bit of pressure. Now I have my left hand on the back of the extruder, and I'm applying pressure with my left thumb. And that's holding, that's pushing in the yellow spring, and it's allowing me to line up the screw into the frame properly, and now I'm able to screw it down correctly. Not a lot of pressure, just a little bit. You'll feel it while you're doing it, and you'll feel the screw going in nicely. You don't want to cross thread that screw. So once you have it nice, you can check the tension by doing that. And now we're going to put the larger screw in here. So now what this screw does is it acts to create more tension on this yellow, these upgraded yellow spring. So as you screw the screw in, it contacts the sheath that is within the spring, and then it pushes out that tension arm. And what that does is create more tension between those two gears, so it grips your filament more. After that, we're going to remove this old pneumatic coupler. This is the one that I had on previously. If you want, you can clip this section. You don't have to. It's not really doing a lot of moving at all. It shouldn't. So I'm just going to put it right in there. Make sure you slide it all the way in. It is a pretty large slide. And then we put the PTFE clamp in to make sure that our Bowden tube doesn't go anywhere. And we are finished with installation. So the next step would be to calibrate our E-steps and then calibrate our flow. I'm not going to go over that because it is the same as it would be with our stock extruder, and I have a video already on that. So if you want to check that out, go back in my archives and check out the E-step calibration video. So this is the contents of the box that comes with our dual geared extruder from the brand Winsinn. We have a spring, a knob, and a black washer, pneumatic coupler for our PTFE tubing, 2 Allen keys, 3 long screws that will hold our extruders to the rail, our gear that drives it all, a clip, and a PTF tubing to introduce filament. This is what the dual geared extruder looks like out of the box. We are going to open it up and show you exactly how it needs to be put together to be installed properly. So this is what it looks like exploded. There are 6 different pieces. The upper and lower chamber, the swinging door arm all the way to the left with its gear already installed. You have a small bearing. You have a white plastic gear that drives the upper gears, and then that circular silver piece is a coupler for the PTF tube pneumatic joint. So we're going to start with the bottom section here. That's with everything removed. Now the first thing we're going to want to do is install the white plastic gear. So that's what it looked like installed. Now on top of mine, you'll notice there is no bearing. You might have one on yours, but it does come off. So this is what it looks like if your bearing comes off. The next shot here is going to show you where the bearing goes. So if you have a small little bearing kicking around in your box, it goes on top of that white plastic gear. Next, we install the threaded insert for the pneumatic coupler. It just slides right in there, and the top chamber will lock it in place. Now we're going to look at the other portion of it, the upper section. This is the arm with the gear installed and the plastic section with a little shaft coming down. Now these two pieces join. It's very hard to mess this up, but this is what it looks like. The arm section with the gear slides onto that shaft. After we have both pieces assembled separately, we slide them over the top of each other. They fit in very nicely, and it's a snap fit. You want to make sure each corner and each side is snap fit to the other. This is what it looks like completely installed with the arm closed. Now the last thing we need to do is add the tensioning nut to the arm. So we start here. We have the knob, we have the spring, and we have the washer, and we assemble them just like this picture here. The next thing we want to do is install them onto our arm. There's a threaded section in the plastic extruder itself, and there is a hole within that arm, and it's threaded through the arm into the threaded section, and tensions our extruder. Now this is what we will depress in order to remove or advance filament. We'll pull outward on that plastic arm as we depress the metal knob. Now we're on to removal. The first thing we want to remove is the screw keeping tension on our tension arm. Next, we're going to take this pneumatic coupler out and remove the Bowden tube. You could have done this first. Also, what you want to make sure is the printer is unplugged, as well as the extruder motor. I didn't do that because I'm a dum-dum, but you should be doing that. Next, we go ahead and we take the 3 screws that we can see right now, the 2 at the top, and then the one that's in the tensioner arm. Now, when you're doing this tension arm, when you're removing the screw, just be careful because after it's completely loosened, the flush bearing or that smooth gear and the spring will pop out. So, as you can see right here, get a hand in there, make sure nothing falls all over the place. Now that exposes our last screw, and now make sure you put your hand under the extruder because that's the only thing holding this up. After you take that last screw off, the extruder is falling down from the frame, so you want to make sure you are going to catch it. And then we take the plastic extruder top off. So the first thing we want to do before we begin installing our plastic extruder is set up the stepper motor. We're going to remove the gold gear that was on the stepper motor, and we're going to replace it with the gear that came with our new dual gear extruder. Now, an important thing is we want to make sure that we are installing the grub screw onto the flat side of the stepper motor shaft, and we want to make sure that that grub screw is facing upwards. Now, next, to check distance, we're going to use that bracket that came in the box. Now, we don't need to use this bracket on the actual machine for installation, but it will help here to serve us as a distance guide to see exactly if the gear on our plastic extruder and the gear on our stepper motor that we just installed are lining up properly. So the next thing we want to do is place the plastic extruder onto the stepper motor just like that. And we can go around to the front and we can see if those 2 gears are lined up properly. If you want at this point, you could spin that white plastic gear with your thumb or your finger, and you can see if both of the gears are contacting each other and spinning properly. So now we're ready to install our plastic extruder. We want to make sure everything is assembled properly. You can spin that plastic white wheel at the bottom, make sure it's spinning freely. Now we have our long black screws already installed because it's going to make this a lot easier. We put the 3 screws in through the plastic, and then we line them up with the mount on the extruder. Here we have our extruder motor. We want to make sure that the connector is facing outward away from that glass bed. And all we do is set the stepper motor right inside the plastic extruder on top. And now we line up those screws. You can see, feel it snap in, and we screw everything down and tight together. So there's only 3 screws holding this extruder motor in, unlike the 4 that the original one had. But once you get them all in, you make sure they are snug, and this thing will not go anywhere. After that, we want to put this PTFE tubing in. It helps introduce filament into this extruder because the gaps are so small. I put a little marking there afterwards. I snipped it to appropriate length, and then I reinstalled it. And now we're going to install the filament. You put it in through that PTFE tubing we added, and then we're going to depress that knob and pull out on the lever. That's how we loosen the tension on the gear inside and move filament in and outward. So you'll see how I'm pressing against that knob, pulling against the lever, and I'm able to introduce filament. So there's one last thing I want to cover before we plug in this extruder motor. Now, some of these BMG style clone extruders require our stepper motor to move in the opposite direction. If the extruder you purchase doesn't mention this in the instructions, then you can most likely skip this section. So in order to make our stepper motor move in the reverse direction, there's 3 ways we can go about this. The first one is through our firmware. Secondly, we can go into the terminal and we can make our E-step number a negative number. And lastly, and how I would do it, is physically remove the wires and swap them around. So what we're looking at here is the JCT connector for our extruder motor. So right here where the red arrow is, that's what I'm going to call wire number 1. And we'll go from right to left, 1 through 6. So 1 is the wire we're going to want to swap. 2 is an empty space. 3 is a wire that would stay there. And then number 4, right where this red arrow is, that's the other wire we're going to swap. So what we would do is take tweezers or another small instrument and lightly open up the plastic tabs holding those wires in. Remove them both, swap them. So 1 goes into 4 and 4 will go where 1 is. After that, we reclose the tabs on the JCT connector, make sure everything's tight, and that's all we have to do. Now, when we go ahead and plug this into our extruder, the stepper motor's direction would be reversed. And that's what some of these BMG clone styles call for. Now, I want to make this clear that not everyone's going to have to do this. Most likely you won't. There's only a small number of these clones that require you to reverse the stepper motor order. So if yours doesn't say that, skip this part entirely and completely disregard it. After everything was installed and my extruder was rehooked up into the stepper motor, I went to my LCD screen and I extruded 100 millimeters of filament. Now, as I expected, because of the gear ratios, the length of filament that was extruded was severely short, not nearly 100 millimeters. So I knew I had to increase my E-steps. Through the LCD screen, however, I found I can only get up to around 186 millimeters per second, which was way below what I wanted to start at, which was 415 millimeters per second. So to do that, I had to go into my terminal through Pronterface, which I'm going to link the video right here that I went through in my last PID tuning video. And after I accessed the terminal, I inputted this code, M92E415, and hit enter. That changed my E-steps to 415 millimeters per second. After that, I ran my extrude of 100 millimeters again through the LCD screen, and this time I got much closer. I was only a few millimeters off. I plugged it into my formula for E-step calibration, again, a video I did in the past. I got a number, 407, and I went back into my terminal. And now this time I put M92E407, and that changed my E-steps to 407 millimeters per second. I extruded 100 millimeters of filament one more time. That finally let me extrude the exact amount of filament I asked for, 100 millimeters. And I went in through the LCD screen and I stored my configurations. This way, when I turn my machine off, the E-step number would be saved. So oftentimes when removing filament, you'll heat the nozzle up to the temperature. You'll need to push a little bit of filament out to get it out of the nozzle, and then you can remove it. However, the bulb that forms at the end would then get caught in the extruder. It's sort of a good thing. It means that the pathway in the extruder is very narrow. However, it makes removing filament a pain. A workaround I found was to remove the PTFE tubing, snip the filament right before the bulb, and then I was able to remove the filament properly. It's just a good thing to know. 2 dual gear extruders installed. The old ones have been removed. What an upgrade, what a performance increase. And I have to tell you, TPU on the encased plastic extruder, printing as we expected, very well. All metal extruder, we weren't sure about it. It's printing TPU phenomenally. So I'm very surprised, but I am happy about being surprised because it is such an upgrade. Not only functionally, it's also increasing the breadth of what we can print. TPU is working on both. So thank you guys for sticking around to the end of this video. I really hope you learned something. That's why I'm doing these, just to try and get people who are new to the printing community, especially through the Voxelab Aquila because of its price point, so they can see kind of how everything's done. Things are broken down. I try and go through the minutia of everything. I know it's long, I know it's boring sometimes, but I know people like to see all the process. So if you like what I'm doing here, please like the video below, subscribe to my channel. I have a new video coming out every week. I think next week might be Z offset and baby stepping our build plate. It's such an important topic. I don't think enough people know all about it that I want to cover. So if you subscribe, you'll get notified when that comes out. And of course, guys and girls and everyone else, as always, keep on printing.